In this example, we're going to look at this limit of this rational function. Okay, so to start, we can try by plugging in 3. We plug in 3, we're going to get negative 6 in the numerator and 0 in the denominator. Okay, so I'm getting a constant over 0. That should raise a red flag to me right away and tell me that, look back at my function to see what is happening when x is 3. When x is 3, the function here is not defined, but the limit may still exist as x approaches 3. So if I have a rational function where it's not defined, I'm either going to have a hole in the graph or I'm going to have a vertical asymptote. And in this case, since we can't factor this function any further, I know I've got to have a vertical asymptote when x is equal to 3. So I have a vertical asymptote. Okay, so to figure out if the limit exists as x approaches 3, I need to figure out what my right hand and my left hand limits are doing as they approach this vertical asymptote. Are they shooting up to positive or negative infinity? Let's look at the right side first. So I'm going to look at the limit as x approaches 3 from the right. So now notice, when x is approaching 3 from the right, this is telling me that x is greater than 3. If x is greater than 3, then what's going to be the sign of my denominator? Well, that tells me then that 3 minus x is going to be less than 0. So that tells me that my denominator, as I'm coming in from the right, is going to be a very small negative number. So I'm going to have a small negative. Let's look at the sign of my numerator as I'm coming into 3 from the right. So I'm coming into 3 to 3 from the right. My numerator is going to be getting closer and closer to negative 6. So this is also going to be a negative number. Not a small one, just a negative number. Okay, so what's going to happen? I have a negative number over a number that's getting smaller and smaller and smaller, and it's still negative. That's going to go to a positive infinity. So this tells me that my right-hand limit is positive infinity. We need to do the same idea from the left side and see if that limit from the left is shooting up to positive or negative infinity. Okay, so let's look at the sign. So my numerator, as I'm approaching 3 from the left, my numerator is still going to be getting closer and closer to negative 6. So my numerator is still going to be negative. What's happening to my denominator? When x is less than 3, that tells me that the quantity 3 minus x is going to be greater than 0. See, all I did with this inequality is just move the x to the other side, and you're left with 0 is less than 3 minus x. So that tells me that in the denominator I'm going to have a very small positive number. Okay, that positive number in the denominator is going to get smaller and smaller. And so as we take this limit, this is going to be a negative over a small positive. That's going to go to, that's going to go to negative infinity. It's going to go to negative infinity. So my left-hand limit is negative infinity. And so we could do a rough sketch just so we can picture what this function looks like. We have this vertical asymptote when x is 3. As we're coming in from the right, this is shooting up to positive infinity. As we're coming in from the left, this is shooting downward to negative infinity. And then if we did a little bit more analysis, so we looked at what happened as x was getting huge, as x went out to positive infinity, we'd see this is actually approaching y is equal to 2. So we also have a horizontal asymptote. But we were less interested. We're much more interested right now in looking at what's happening around our vertical asymptote. Okay, so because the limit from the left as x approaches 3 is not the same as the limit from the right as x approaches 3, we can say that the original limit we've been trying to find does not exist. And that's our final answer.